Okay, so today we are going to talk about continue talking about the basic types and their operations, but not the level 1 basic or level 2 basic. So still we have collections of values that we can put together into collection types. So there are different types of collections in Python. We're gonna talk about sequence types today. So last time we talked about the most basic ones, like the numeric values, the Boolean and text. And today we're going to talk about sequence. We're not going to talk about sets and dictionaries today. We're just going to talk about the strings and listed tuples and ranges. Okay, but all of them are considered compatible. So all these collection types are considered compatible with each other. Okay, and they're called iterables. Okay, so now we started talking about strings last time, right? Now, string has a very special nature. It can be treated as a literal value at times, and it can be treated as sequence value as well, but it's not identical sequence. Okay, we'll see the difference of it now, but it's still considered iterable. All right, so it's still considered compatible with other sequences, but there are some subtle differences we are going to talk about today. So before we talk about these types, we need to understand the difference between mutable objects and immutable objects. Are you familiar with that concept, mutable objects and immutable? So mutable means it can be changed. Immutable means it cannot be changed. So what does that mean? So what does that mean? So let's start with talking about the strings. Okay, so if you have a string, when you say x equals ABC, like in the example. Okay? So x equals ABC, like you can see in the example. Now you see here, there are a couple of things happening. So one, there is a variable with the name x. So in the memory, there is a location that represents that variable that has the name x. Okay? Two, there is the creation of that object that has this value. So somewhere else in the memory, there is an object created that has the value that this string. So let's say this is an address 123. So another place in the memory. Okay? Then the third thing that's happening here is the assignment. So when you say x equal this string object, you're just taking the address of the object and storing it in the variable that we call x. Okay, so that variable is just pointing at the object. Okay, now if the string was mutable, which is not the case, I just want to mention that for the sake of comparison. If the string was mutable and I said x plus equal, or let's say let's take the long form, equal x plus xyz. Okay, so this is a concatenation, right? So what happens here is that we read the value of x. So in order to evaluate this expression, we read the value of x, which is now ABC. All right. Apply the operation, which is the concatenation. So the result of this application is ABC XYZ. And then if it was mutable, then you remove the old value and replace it with the new value. That's if it was mutable. Okay, so if we have a mutable object, it works like this. And try to change it, the old value in the object will be removed, the new value will replace. But the reality of the string is that it is immutable. So what does it mean that the string is immutable? When you make a change like this, even though it looks like we are assigning to the same variable, what happens is that a new object altogether would be created for that new value. So that new object would have the new value. And let's say this is an address 456. Okay? And then the assignment would be to remove the old address. So now it's not pointing here anymore. And store the new address. So now X is pointing at this object. Okay? So there's a danger here that if you use it a lot, you can like waste your memory. Because well, eventually there's garbage collecting that when there is an object that nobody points to, it will be erased. But you need to be careful what you need to watch. Okay? So is this clear? Yes.
How do you make something like immutable?
So we don't make it. It comes with the language, comes with the settings. So you just need to look at the documentation to know whether it's immutable. Okay? Okay. So now, as you can see here in the example, here it may appear as if we changed the value of X, but we actually changed the entire object altogether. We just X has a new reference to another object. Okay? And that's what is explained here. Okay, now let's talk about the sequence types that we have today. So first, all of them belong to the same family, so all of them iterable, so all of them has the same parent, if you remember the inheritance concept. So there are some common features, some common operations. The common operations that apply on any of these would be the n is it's like a question. Okay, so if you want to know whether a value is in the sequence, you use the operator n. Obviously, not n is the opposite. Okay, the plus with any of the lists, just like it was with the string, it's concatenation, which means that it copy that. Put these two lists or two sequences together. Okay, so it works with lists and tuples of all. It works exactly the same way like it works with the strings. Okay, so it's concatenation. The star, again, is similar to how it works with the strings. It's repetition. So we repeat the list to this number of times and concatenate them together. All right. Now you might be familiar with this symbol. The square brackets when you use it with a collection. What does it mean? Index. Did you say index? List. Well, not necessarily a list. Or any list or tuple or strings or ranges you can use the symbol with them to refer to a specific element. So the index. Okay. So if you say S square brackets of 0, that's the first element. Of 1, that's the second element, and so on. So there's square bracket here means the index. Now these two, still using the square brackets in this context mean we are dealing with indices. Okay, so if you're given one item or one value, that's just when you want to read the value at this particular location or this particular index. Now, what would it mean if we have a column like this between two values? What do you think? You have a guess?
Iterate.
Iterate? Kind of. So it gives you a slide. So the result of this is another sequence starting from index I to index right before J, not index J, to the index right before J. Okay? So that gives you a slice. So the result of this is just one element. The result of this is another sequence that starts from I to right before J. Okay? Now, when we add this third value here, that's the step. So by default, it's 1, which means that when you move from the first value, so let's say you want your range from 5 to 8. Okay, so that means 5, then 6, then 7. Okay, that's because the step by default is 1. Okay, if you want a step of 2, then it would only be 5 because the next, or it would be 5 and 7. Okay, because every step we skip 2 elements, 2 values. Okay, now length is a function. So a function, when you send the sequence to the function that's called the len, is short for length. It gives you the size of the sequence. Minimum gives you the smallest value, maximum gives you the biggest value. Now the one thing I want to emphasize here, now this looks like a function, right? So when we say s dot index, so index is a function. Okay, because we see this parenthesis, we know that means function, right? But what is happening here? So this is a notation that you should be familiar with. The use when you're using the square brackets, when we're not talking about lists and we're not talking about indices. So the square brackets is just a description of the sentence. It's not original in the statements, in the expression. Okay? So that just means it's optional. So we have two options here. So at least this index function takes at least one value, okay, and it gives you when the index of that value if it exists. Okay, so Gamma searches for a value in the sequence and give you the index of it if it exists. Right? Optionally, you can add another argument to this function. So you see this first square brackets here, the first set of square brackets. Means that this I is optional, you can add it, so that's the beginning of where you want to search. You don't have to start the search from 0. You can start the search from like later in the list. Okay? And then another square bracket here to indicate that the third argument is also optional. So you can specify a range beginning and end, or just the beginning and then automatically go until the end of the entire sequence, or just a value and it will go from the very beginning to the end. Okay, so when you see this square brackets in the description of the sentence, if you're not talking about lists or indices, then it's just a description. It's just a notation to describe the sentence. It's not original in the expression. Okay? Any questions about that? Oh yeah, so there's another thing here. We are familiar with indices, but in Java you have arrays. You can access the elements of the array with indices, and it has to be 0 and above, right? It has to be positive number of 0. Now in Python you can use a negative number, but that's just it looks at lists from the end. So the negative number would be replaced by the length plus that number. So I itself is a negative. Okay, so if I say -1, so that means length -1. If I say -2, it means length -2. So that's just looks at the sequence from the end. But like you cannot consider the last element as 0, so it has to be starting by 1. Okay. Yes.
Can this negative number, like, let's say it's like the length is 2, so you put a -2?
No, you can't. You have to be in the same range, otherwise it will give you an error.